Hello everyone, in this video we will be solving the problem 153, find minimum in a rotated sorted array. In the rotated sorted array, we need to return the minimum element in this array. If we look at example number 1, the variable nums contains 3, 4, 5, 1 and 2. If you just skim through all the elements, the minimum element is 1. If you look at the explanation, the original array was 1, 2, 3, 4, 5. It was rotated 3 times, which gave us the result as 3, 4, 5, 1 and 2. There is a note added to the problem that we need to write an algorithm that runs in O of log n time. So we cannot write a solution that iterates through all the elements, giving a time complexity of O of n. Let's switch to whiteboard session and think how we can solve this problem. Let's use this as an example. If we just look at the input, the minimum element in this array is 0. And the simplest approach to find the solution is going to be like iterate through all the elements and compare it with a minimum value that we are storing somewhere in a different variable. And after iterating through all the elements in the array, return the value in the variable. But the time complexity with that solution is going to be O of n because we are iterating through all the elements in the array. Another way of solving the problem is to compare the adjacent values and see if at any given point of time there is a decrement. Because the problem statement states that this is an ascending order or it is already sorted, so the numbers are always going to be greater than the previous one. So 5 is greater than 4, 6 is greater than 5, 7 is greater than 6. At any given point of time, this condition is not satisfied, like in this case, we should return the next value, which is 0. So 0 becomes the minimum element in the list. That is also a potential solution, but again, thinking from the worst possible case, the time complexity is still O of n because we will have to iterate through all the elements and then return the result. Let's think if we can apply a different algorithm to solve this problem. As the problem statement states that this is a sorted array and all the elements are unique, maybe we can try to use binary search tree algorithm to solve the problem. So in a binary search tree algorithm, we usually compare the median of the array with the ends and see which one is greater. So we can use that same logic to solve this problem. So here my left will be 4, my right will be 2, and my medium is going to be 7. If, for example, this was a sorted array, my left is always going to be less than medium and median should be less than R. If this is true, it means the array is sorted correctly. Because this is a rotated array, either of the condition is not going to be satisfied. Let's start with comparing the medium with the R element. So my medium is 7, R is 2. Is medium less than R? So this condition is not satisfied. It means that within this combination, we have a minimum element because 7 should always be less than the element on the right hand side. So because this condition is not satisfied, I will have a minimum variable where I'm going to be holding the minimum variable that we have calculated so far. So between these two numbers, medium and R are the right, R is smaller than 7, it means R is potentially a candidate to be considered for the minimum element. So my current minimum before starting the loop is going to be the maximum value, int.max. If I compare this int.max with this value 2, I will get the minimum as 2. As I know that there is a potential minimum value available only in this region, I do not need to check anything in the first part. So I can totally ignore this and I can update my L value pointing to the next element in the second section of the array. Because I have already looked at 7, I don't need to use it again. So I can directly jump to the next element and use that as a reference. So my new values of L and R is going to be L will be 0, R will be 2. With these L and R, my median is going to be 1. Now I need to compare if L is less than M and M is less than R. Like before, we were looking at medium and R. So this condition is met because 1 is less than 2. It means this part of the array is valid. We need to look at the first section of the array. With M less than R, it means that the minimum candidate needs to be updated. So I need to compare my minimum value with M. As M was lower than R, we need to compare 1 with 2 and get the minimum. So my new minimum will be 1 and I will update the L, M and R values. I will not be updating L at all. I will be updating R. So now R will be pointing to 1. But now that I've already gone through 1 in my previous iteration, instead of doing 1, I will use the previous value before 1. So I will be using R as 0. So my both L and R are pointing to the same value. My medium is also going to be pointing to the same value. My L, M and R pointing to 0. Is M less than R? That is incorrect. So I will update my L to point to M and then compare 0 with the current minimum element that we have saved in the variable. So in this case, my new minimum will become 0 and I will update my L to the next value of 0. So the next value of 0 is 1. So L will become 1. My R is still going to point to 0. Here's the breaking condition. We will only run this loop until L is less than or equal to R. Whenever this condition fails, it means we need to break the loop and return the minimum that we have calculated so far. Because if we continue further, we are not going to get any new results. It's always going to be the minimum that we have calculated so far. So in this case, we will break the loop after this condition is failed and return whatever the minimum that we have calculated so far. I hope you were able to understand this approach. We tried to use the binary search tree algorithm to our advantage and just tweak the conditions a little bit so that we can find the minimum element in the array. To solve this problem, we broke it down into 3 iterations. We first did with median is equals to 7. Then we tried with 1 as a median and then 0 as a median. So we did solve this problem with 3 iterations only. So our time complexity is O of log n, where n is the number of elements in the array. Let me show you how we can solve this problem using C#. Here is the C# implementation. In the main method, we start with validating if the nums is null or not. If the nums is null, we return -1 as the result. Then we initialize the variables. We are setting this return value as int32.max. The left index is 0 and the right index is num of net -1, so which will give us the last index. Then we are running a while loop until left is less than or equal to right. If this condition is met, the loop will be executed, else it will jump off. Then we are calculating the mid of the range based on left and right values. Once we get the mid, we compare the value at that mid position with the right position. If the mid is less than nums of right, which means it is in a right order, then we update the right value to mid minus 1 because the second part of the array is valid. Then we calculate the minimum value based on the current return value and the current mid, because the current mid value is less than the right, so it means it is definitely lower. So we do that calculation and save the minimum value in this return value variable. If the mid value is not less than right, let's say the mid value is greater, then it means that the first part of the array is valid. So we need to update the left index to mid plus 1, and we update the return value and calculate the minimum between the current minimum value and the right value. After the loop is complete, that is left is greater than right, this condition, the flow jumps out of the while loop and we return the return value variable. I hope you were able to understand this approach and how we solved it using binary search tree algorithm. If you have any questions or concerns, please feel free to reach out to me. I will be adding the link to the source code in the description below, so you can check that out as well. Thank you for watching this video, and I will see you in the next one.